Hello guys, welcome back to the channel. I am Neeli, currently studying at Sri Venkateswara College of Engineering, Bangalore. Today, in this video, we will learn to create animated characters using physics. Now let's check out the outline of the topic. First, we will go through the basic principle of animation creation. Second, creating a simple animated character. Third, adding complexity to the animated character. Fourth is fine tuning of the animated character, that is, refining the animation. Lastly, we will see examples of physics in professional animation. So let's get started. What is animation? Animation is the creation of the illusion of motion and change by rapidly displaying a sequence of static images that minimally differ from each other. This technique can be used to bring characters, objects, and scenes to life in the visually engaging way. Animation can be found in various forms, including 2D hand drawn, 3D computer generated, stop motion, and more. It is widely used in industries like film, television, online gaming, and online digital media. Creating animated characters using physics is a fascinating and intricate process that brings life to our screens. This process involves a deep understanding of both the artistic and scientific aspects of animation. The artistry comes into play in the design and personality of the characters, while the science of physics is crucial in making the characters move believably. For creating a simple animated character, we need to follow the following steps. First, conceptualize the character. Start by sketching the character. Keep the first animation as simple as you can. A basic shape like a circle or a square can be a good starting point. Second, understand the principles of physics. Get familiar with the basic physics principles such as gravity, force, and acceleration. These principles will guide the movement of characters. Third, use animation software. Choose an animation software that allows you to apply physics principles. For example, software like Adobe Animate or Blender have built-in physics engines. Continuing with the last slide, the fourth step is to create the animation. Begin creating a keyframe for your character's starting position, then create a second keyframe for the next significant movement. Fifth is to apply the principle of squash and stretch. This fundamental principle in animation gives the illusion of the weight and volume of a character. For example, when a character moves, it should squash when it lands and stretch when it moves quickly or jumps. Last step is to apply physics. Adjust the properties of your character, such as mass, gravity, and velocity, in the software to make it seem more realistic. For example, a heavier character will fall faster and harder than a lighter one. For refining, play back your animation and make adjustments if needed. After creating a simple animated character, add complexities to make it realistic, such as gravity and weight. Make sure your character obeys the laws of gravity unless they are in a zero gravity environment. This can be shown as they move and interact with their surroundings. Character should also have a sense of weight. For instance, larger characters should move slowly and have more impact, while smaller character should be lighter and quicker. Inertia and momentum. Character should continue moving in the direction they were going until something stops them. This can be shown in the way they start and stop moving. A character running should take a few steps to stop running, while a character standing still should take a few moments to start running. Friction is the force that resists the movement of one surface over another. It can be shown in the way characters interact with different surfaces. For example, a character might slide on a sleek surface but have a firm footing on a rough one. Force and impact. When a character exerts force, like throwing a punch or jumping, it should have an appropriate reaction. For example, the character throwing the punch might move slightly backwards, while the character being hit might be knocked back. Balance and posture. Characters should have a sense of balance. If a character stands on one foot, they should lean to counterbalance. Coming to fine tuning of animated characters. Hair and clothing. If a character is moving, their hair and clothing should also move. For example, if a character quickly turns their head, Their hair should follow the movement a fraction of a second later. Facial expressions, these can be used to enhance the main action. A character's facial expression should reflect the efforts they put into any action. Arms and legs. If a character is walking or running, their arms should swing or move in opposition to their legs. This is a natural movement that helps to maintain balance. When the main action is completed, there should be a follow through. For example, if a character jumps and lands, their knees might bend to observe the impact and straighten again. Overlapping action comes into the role when different parts of the character move at different rates. Let's see some examples of professional animation that has been created using physics. The game of Angry Bird is a perfect example of momentum and collision. The birds are launched at a certain speed and angle, and also they follow a parabolic trajectory due to gravity. When they hit the structures break apart based on the board's momentum and the structure's strength. The GTA series is known for its detailed and immersive animation. The game uses combinations of physics and animation to create a realistic and interactive world for players. It includes character animation, vehicle physics, environmental interactions, collision physics, character physics, etc. A great example of physics in professional animation is the Pixar film Toy Story. In this film, the animators went to great lengths to ensure that the movement of the toys were grounded in real world physics. Let's go through the summary. Creating animations using physics involves applying principles of real world physics to make characters more believable and lifelike. This includes considering aspects like gravity, weight, inertia, momentum, friction, and balance in the character's movements and interactions. Additionally, secondary actions such as the movement of hair and clothing or facial expressions can add depth and complexity to the animation. These principles help in creating more realistic animations, enhancing the overall viewer experience. With this, I would like to conclude the presentation. Thank you so much for watching. I hope you found the video helpful. Until next time, take care and stay tuned.